Yes.
Good evening, sir.
Yeah, good evening, everyone. So today you have your chemistry class? Yes. Good evening, everyone.
Good evening, sir.
So we had completed one chapter, acids, bases, and salts from chemistry. Okay. Is there anyone who is having any doubt from those chapter, from that chapter, acid, bases, and salts? I think where you can face the doubt, and I had also promised you that I will be taking the problems or the problems from, or once again I will be taking chlor-alkali process, right?
Sir, once can you explain plaster of Paris?
Okay, plaster of Paris, fine. So I will explain plaster of Paris also. Is the screen visible to everyone? Sumuk?
Yes, sir.
Okay. So see, we will start with chlor-alkali process, and then before ending the class, I will be telling you about the plaster of Paris also. Okay. So let's continue with chlor-alkali process. See, the chlor-alkali process is the common process of, it is the process of obtaining some products from common salts. So why the name is called as chlor-alkali process? Because of the products that we obtain from here. So during the chlor-alkali process, we obtain the products from common salt. So how do we obtain these products from the common salt? See, in a chamber or in a beaker, we take a solution of common salt. So can anyone recall what name was given for the solution of common salt?
Brine.
Brine, very good. So a concentrated solution of common salt is taken in a beaker, which we call as brine. So this concentrated salt solution, which is about 30 to 40% concentrated salt solution. Okay. So this is our concentrated salt solution, which we call brine. It is 30 to 40% concentrated. 30 to 40% concentrated NaCl in water. Now, with this brine, we perform electrolysis using two electrodes. So we use two electrodes, and we make one of the electrodes as the positive electrode, the other one as the negative electrode. So as you can see, I have made the two electrodes. One of them I make them as positive, and the other one I make as negative. So here I make this electrode, one of them as positive, the other one is negative. So this electrode being negative and this electrode being positive. So see, here we will be talking of 3 points. First of all, we'll be talking what happens in the solution. Then we'll be talking what happens at the positive electrode and what happens at the negative electrode. So first of all, we'll be talking what happens inside the solution. Okay. We'll also keep on writing the reactions. Okay, so see what happens inside the solution. So in the solution, we have water and NaCl. So see, from NaCl, our NaCl breaks down to give Na plus and Cl minus. These are the two types of ions which we obtain from it. Whereas from water, we obtain H plus ions and hydroxide ions. So what all ions are present in the solution? Yes, which all ions are present in the solution? Arav? Arav? Arav, are you there? Okay, so Arav, if you are not able to unmute yourself. Siddharth?
Sir, can you repeat the question?
Okay. So what are the ions present in the solution?
Sir, H, Na plus ions, Cl minus ions, H plus ions, OH minus ions.
Okay. So always remember here we have 4 types of ions present in the solution, and out of these ions, nothing happens to this Na plus and hydroxide ions. So the reason I will discuss that why Na plus and the hydroxide ion they remain in the solution, whereas H plus ion and Cl minus ion they move to respective electrodes. For example, let us say this chloride ion. So all the chloride ions they would be moving or they will be trying to come near the positive electrode, whereas the Na plus electrodes they themselves they are positively charged. Sorry, H plus ions. The H plus ions they are positively charged, so they will try to stick towards the negative plate. They will be attracted towards the negative plate. Okay, so now will be our discussion now moves towards the 2 electrodes. We are discussing now for the positive electrode. So here we have what happens at positive electrode. Okay, so which ion will be moving towards the positive electrode? There, which ion will be moving towards the positive electrode?
Sir, OH minus.
OH minus ion?
Yes, sir.
See, in the beginning only you keep these locked. The Na plus ion and the hydroxide ions, they are locked. I will tell you why they are locked and why they will not be moving to any of the electrodes. They won't be moving towards any of the electrodes. They are locked. Okay. So now you are left with only 2 electrodes, H plus ions and chloride ions. So which ion
So the
will
gas
be,
is released, right?
but which ion is moving towards the positive electrode? Out of the
Cl
2
minus.
ions present, okay, out of the 4 ions, out in the 4 ions, Na plus and hydroxide ions, they are locked, they will not be moved. Okay. So which ion will be moving towards the positive electron?
Cl minus.
Cl minus. Okay. So at the positive electrode, this Cl minus ion will be moving, and it is Cl minus chloride ion. See, that means it has accepted one electron and it is being attracted towards the positive plate of this electrode. So this positive plate will gain the electron of chlorine. It will gain the electron of chlorine. As a result, see, at the positive electrode, this chloride ion, it gives out one electron and becomes itself chlorine. So one electron which this chlorine had taken up, that electron has been taken up by the positive electrode and it is transported to the positive terminal of the battery. Okay, so now you are left with chlorine atom at the positive electrode. As soon as another chlorine atom is formed at the positive electrode, we get chlorine plus chlorine gas at the positive electrode. So which gas will be liberated at the positive electrode?
Chlorine.
Chlorine gas. Okay. Also, can anyone tell whether oxidation or reduction is taking place at the positive electrode? In this reaction, the reaction which I have listed out here, from this reaction, can you tell whether oxidation or reduction is taking
Reduction.
place?
So is it
Anyone?
reduction?
No, it's not reduction, it is oxidation. See, loss of electron. Chloride ion is losing electron. Can you see in this reaction? On the reactant side, you have the chloride ion, and on the product side, we observe that chlorine has lost one electron. And as per the definition we had studied, that loss of electron is oxidation. Right? So at the positive electrode, here we observe oxidation occurring. Okay. And hence the name is given as anode. The name of the positive electrode is given as anode because oxidation occurs at this plate. Got it? Chlorine atom is losing electrons, so hence oxidation occurs here. Now let's say what happens at the negative electrode. So what happens at negative electrode?
Hydrogen gas is formed.
Hydrogen gas. So how it will be formed? Which ion will be moving?
H plus.
H plus. Okay, so at negative electrode, the ion which is left out is H plus. So H plus ion, it moves towards the negative electrode. And since the negative electrode is full of electrons, there are a lot of electrons which are there on this negative electrode. The reason being it's this negative it is negatively charged. So it has a lot of electron, and hence this hydrogen gains one electron from this and becomes H. You can check plus one charge and minus one charge make it neutral. So hydrogen becomes neutral and another hydrogen atom combines with it to form hydrogen gas. So you observe evolution of hydrogen gas at the negative electron. Okay. So can we say here that reduction is taking place at the negative electrode?
Yes, sir.
Yes. At the negative electrode, reduction is taking place or not? Is
Yes,
there a
sir.
gain of electron?
Yes, sir.
Yes. And the gain of electrons is called reduction. So at negative electrode here, we observe that reduction takes place. And hence the name of the electrode is cathode. So this one, negative electrode is cathode and positive electrode is anode. So here we observe evolution of hydrogen gas. At the positive electrode, we observe evolution of chlorine gas. Okay. So as from this solution, see the solution had four types of ions. it had H plus, it had Cl minus, it had Na plus, it had OH minus. So from this, we are continuously losing hydrogen and chlorine. Okay. So what ions are left here? In the solution, what ions will be left?
Na plus and OH minus.
Which one?
Na plus and OH minus.
Yes. So in the solution here, now this H plus which was there, H plus we have obtained at the cathode, it has moved to cathode, Cl minus, it has moved to anode, and we are left with Na plus and OH minus. So this Na plus reacts with OH minus to form sodium hydroxide ion. So sodium hydroxide or the alkali is obtained in the aqueous solution. So your solution mainly contains caustic soda, which is an alkali.
So that's why it does not move to anode or cathode, no, sir.
No, why it doesn't move? That is a separate issue. Can anyone tell why it doesn't move? Yes, why Na plus and why Na plus doesn't move towards the negative electrode? See, at the for the movement and negative electrode, there are two competitors. One is Na plus, the other one is H plus. So why Na plus is not moving towards this? Why only H plus is moving towards it? And for moving at the positive electrode, there are again two competitors, chloride ion and hydroxide ion. So chloride ion is not moving. Chloride ion is moving, not the hydroxide ion. Why? The reason lies in deep chemistry. Now the deep chemistry tells us that why sodium is not moving. See, sodium, it has a high electrode potential. That means sodium is more electropositive as compared with H plus. Okay, so sodium being more electropositive than H plus, so hence the reason that Na plus is not ready to gain the electrons as H plus is ready. So H plus is more readily available for gaining of electrons as compared to Na plus. So that is the reason Na plus does not move towards the negative electron. Got it? Everyone understood this chlor alkali process now?
Yes, sir.
Okay. Any doubts for anyone?
No, sir.
So
No doubt.
Yes, sir.
Okay. So now the products that we are obtaining. So we obtain three products from here. The products that we obtain from here. So these products are hydrogen, chlorine, and NaOH. Okay. So this hydrogen and chlorine can be combined to form ammonia, to form HCl. So you get another product HCl. Got it? Then this hydrogen which has been obtained, it can be used as a fuel in rockets. It is used as fuel in rockets. Any other use of hydrogen? Yes. It can be used in the manufacture of NH3, which is ammonia gas. Ammonia gas will be further utilized in the manufacture of urea and other fertilizers. Okay, so hydrogen is an important chemical compound, chemical molecule that we are obtaining. Chlorine, it has its properties of disinfectant, and we obtained one of the product where we use chlorine. Does anyone remember the product which we obtained from chlorine?
Bleaching powder.
Bleaching powder. Very good. So we obtained bleaching powder by the use of chlorine. It has disinfectant properties also. Okay. Then now you can see we can also obtain HCl, hydrochloric acid, from it. Then sodium hydroxide, caustic soda, important chemical. It's an important chemical. So it has a wide variety of applications in industries. Also, we have seen some other products which are obtained from caustic soda. Like we observed the formation of baking soda and other things which were there. Okay. So caustic soda is an important industrial chemical, and hence the process of this is very important. Chlor-alkali process is important because you are obtaining the raw products which are very cheap, and you are gaining important products. Now, someone's doubt was regarding POP or plaster of Paris. So, what is the doubt regarding plaster of Paris? See, plaster of Paris, it is a white powder. Plaster of Paris is a white powder that has a property of setting into a hard mass, setting into a hard solid when mixed with water. Also, this process is an exothermic process. So, if you mixed POP with water, since POP is a powder, so it will be mixed with water to take a POP when mixed with water, it sets into a hard solid. The density of this POP is very less. So therefore the solid which is formed, that is not heavy. It's not too heavy. Okay. Its density is less. So this finds a number of applications. POP finds its applications in making of statues, in making false ceiling designs, the statue, false ceiling, or just ceiling designs, other designs they are made of. Also, one of the main applications of this of POP is one of the main applications of POP is in
Theaters.
fixing of bones. Yes, someone was saying something.
It can also be used in theater walls, right? It absorbs
Yeah,
sounds.
yeah, as a soundproof. Okay. Now coming to the chemical nature. So this POP, its formula is calcium sulfate hemihydrate. CaSO4 dot half H2O. hemihydrate. Now, POP or calcium sulfate hemihydrate. So it is obtained from gypsum.
Sir, by heating it.
Huh?
By heating it.
By heating it. What is the temperature that at which we heat gypsum?
373 K.
Yes, 373 Kelvin. Very good. So CaSO4.2H2O. This is our gypsum, and it is heated at 373 Kelvin to obtain POP. And water. So the water molecules, they just evaporate out, leaving behind your POP. Now this POP, it has a very good affinity for water. So if this POP powder is left open, it can react with atmospheric water molecules and get converted into gypsum. So a airtight packing is required so that POP does not come in contact with air molecules. Got it?
Sir,
So, yes.
like I had this doubt. It's like very general, but then why is like the common name of calcium sulfate hemihydrate POP? Why plaster of Paris?
See, it is used for plastering purposes and it's a little bit fancy. Okay, that means decorating purposes. So generally, you see, France and Paris. They are mainly famous for decorative and fancy items.
That's
Maybe
why.
maybe that may be the reason, but I don't know as actually why it's called plaster of Paris. Okay, if anyone
Okay.
can think of any other thing, tell.
Sir, maybe it is found in Paris.
Maybe gypsum from gypsum it was first made in Paris. Okay.
Okay, sir.
So now another important term regarding this POP. See, if you add water to this POP, like in hospital, what happens? You take your POP, that is CaSO4.2H2O, and you add 3/2 molecules of H2O. And you get CaSO4.2H2O. This is gypsum which is solid. Got it? So you have obtained your solid gypsum here. What will happen if you heat POP? And if you heat gypsum above the temperature of 373 Kelvin? Yes? Moksha? Moksha? Pranaya? Okay, sorry.
Yes, sir.
Okay, someone has searched it out from Google and given the answer that King Henry III, who visited Paris in 1254 and was so impressed by fine white walls that he introduced similar plastering in England, where it became known as plaster of Paris. So, so definitely it has its origin from Paris. Okay, Huria Ishaq is asking, how can I access the recording? I think in the content section. If you go to the WeXL app over there in the content section, you have the recorded session. Okay, and the sessions are recorded. Generally, it will be available after around 2 to 3 days. Then next is heating of POP. Heating POP, or you can say heating gypsum above 373 Kelvin. So what will happen? Yes, any answers?
Sir, it
Anything
will
which is
turn into
expected? Yes.
calcium sulfate. It will turn into calcium sulfate.
Yeah, it will turn into calcium sulfate. If you heat this CaSO4 dot 2H2O at a temperature more than 373 Kelvin, 373 Kelvin. So temperature is more than 373. So you get CaSO4, calcium sulfate. This is also called as dead burnt plaster, as now it's of no use. So it's dead. It is also called as dead burnt plaster. Okay. Now what changes? Okay, another question from some other topic. I have this CuSO4 dot 5H2O. So I hope you all of you know that what is this CuSO4 dot 5H2O. Yes, what is this? CuSO4 dot 5H2O.
Sir, blue vitriol.
Okay. It's blue vitriol, or we also call it as crystals of copper sulfide. So what will happen if you heat this? Yes. What will happen? It will lose out the water of crystallization.
Yes, sir.
Yes, sir.
Yes. So it will lose the water of crystallization, and you will be left with CuSO4. The 5 molecules of water of crystallization will be removed. What changes will you expect here? Yes, what changes do we expect here?
The salt turns white.
And sorry?
The salt turns white in color.
Yes. See, this is blue vitriol. It is blue in color. Okay. And if you heat this, you will be getting copper sulfate, which is white color. This is white in color. So a color change will be obtained. Color change from blue to white. Also, the crystals which were there, they will break down into powder. So you will get a powdery substance. And if you add water to it, you will again get blue color solution. Got it, everyone?
Yes.
Yes, sir.
Yes. Anything else from this chapter? Now I think you should be thorough with this chapter. Yeah. Also, one more thing. Always keep referring to these organic acids and where they are found. That means the source of the organic acids.
Sir, formic acid is present in ant
Yeah.
and
Okay. So I'm just let's list it out. So you have formic acid. It's present in red ants. Any other?
The citric acid in citrus fruits.
Okay. Citric acid is present in citrus fruits like lemon and orange.
Tartaric
Lactic
acid.
acid.
Okay. So where do we find tartaric acid?
Tamarind.
Yes.
Lactic acid.
Okay. So citric acid is found in citrus fruits. Then you have lactic acid. It is found in
Milk and other milk products.
curd. Lactic acid is found in curd and tartaric acid.
Acetic acid.
So tartaric acid is found in tamarind. Acetic acid. Where do we find acetic acid?
Vinegar.
Vinegar. Very good. So acetic acid is the common name. What is the chemical name of acetic acid?
CH3.
COOH.
Chemical name. I'm not talking formula. It's name.
Ethanoic acid.
Yeah, it is ethanoic acid. So acetic acid is also called as ethanoic acid.
Sir, I think formic acid is also called as methanoic acid.
Formic acid is called methanoic acid and acetic acid is called ethanoic acid. So acetic acid is found in vinegar. Okay. Where do we find oxalic acid? What is the source of oxalic acid?
Right. It's some vegetable, right, sir?
Which vegetable? Tamarind. Sorry, not tomato. Tomato. Okay. Tomato has oxalic acid. All of it, Ionija?
Yes, sir.
Okay. Where do we find malic acid? See, if you had spoken earlier, I won't have asked you this question. But you're silent, you're not answering anywhere. So you need to answer. Where do you find the malic acid? Source of malic acid.
Sir.
Yes,
Sir, apple.
apple. Okay. It is found in many fruits. Malic acid is found in a number of fruits, like you can find it in unripe mangoes, apples, and grapes.
Sir, what happens to the mango, like the malic acid present in mangoes after they ripe then?
So after they rise, so obviously malic acid oxidizes. Okay, it gets oxidized to be converted into certain other substances.
Okay, sir.
Okay, so by all of you, I think we have finished this chapter thoroughly, and you should be prepared well for the test of this chapter. Okay, by all of you, see you again in next class.
Sir, what are we going to do on next class?
Hmm?
What are you going to do on next class? Next.
Okay, from the next class, I think of starting with a new chapter. And in physics, I think I should be revising with human eye and colorful world. There are some still complications in that chapter. So I'll be revising with human eye and colorful world. Got it?
Okay, sir. Thank you, sir.
Okay, by all of you.
Thank you, sir.
Thanks.
Bye, sir. Thank you, sir.
Okay, bye.